In this video, we are to estimate the mean and the variance of a log-normal distribution using the maximum likelihood estimation. For more on this topic, you need to subscribe to this channel. Solution. To estimate any distribution using the maximum likelihood estimation, the first thing to do is to take the likelihood function of that distribution. So the likelihood function of x into mean and variance is equal to the product sum I running from 1 to n of the distribution given. Exponential negative ln x minus mean raised to the power of 2 all over 2 sigma squared. So if we take the product sum of this, we get something like this. Equal to, it means our likelihood function will be equal to, the first thing is 1 all over x sigma square root of 2 pi, we use this sign, minus ln x minus mean squared all over 2 sigma squared, multiplied by, we get another one, 1 all over x sigma square root of 2 pi. The second one, this is the first, this is xi, exponential negative the ln of x minus mean all squared all over 2 sigma squared. It continues. This xi multiplied by, it continues, multiplied by 1 all over x sigma square root of 2 pi raised to the power of n exponential negative ln of s minus mu all squared all over 2 sigma squared. So it then means that our likelihood function, mean sigma, will be equal to 1 all over x sigma square root of 2 pi raised to the power of n, because it will go n times, multiplied by the exponential negative ln x minus mu raised to the power of 2 all over 2 sigma squared. So this is what we get. This is what we get. If we take the likelihood function of this distribution, the log normal distribution, we'll get this. So the next thing to do for the maximum likelihood estimation is to take the log of this function. But before we take the log, we need to rearrange this well so that it will be very easy for us to compute. So it then means that rearranging it, our likelihood function will now be mu sigma will be equal to, say, x sigma square root of 2 pi raised to the power of minus n, because of that one, exponential negative mean x minus mu raised to the power of 2 sigma squared to be equal to, this can multiply this to give us x raised to the power of minus n multiplied by sigma raised to the power of minus n multiplied by If we remove this square sign, this square root sign, we get 2 pi into negative n all over 2 multiplied by exponential negative ln x minus mu. Sorry, this will be the sum total will give us summation of this. So this is summation of, and this is to give us, this will give us negative summation of ln x minus mu raised to the power of 2 sigma squared. So if we take the sum of all of these things, because of this x value, we get summation of ln x minus mu raised to the power of 2. So this is what we get to be our likelihood function. The next thing to do for the maximum likelihood expression is to take the log. If we take the log, we will get log the likelihood function of x mu sigma. To take the log of this function, we get n will come over here to give us negative n log x. Because of this negative sign, we'll have negative n log sigma. Because of this, we have negative n all over 2 log 2 pi. If you take the log function of an exponential, if we take the log function of an exponential, we get that same thing. So we have negative summation of ln x i's minus mu raised to the power of 2 all over 2 sigma squared. Let's take this as our equation star because we will recall it back. So the next thing to do is to differentiate with respect to the mean first. We differentiate with respect to the mean, which is the differential of the log function of the likelihood function mu and sigma all over the mean. We get, since there is nothing like mu here, this place turns to 0, minus the same thing here, it turns to 0, minus the same thing here, it turns to 0. Then this, we take the partial derivative, which is negative 1 all over 2 sigma squared. We differentiate this, we get multiplied by 2 sigma ln x minus me raised to the power of 2 minus 1. So we get, of course, this will cancel this. Multiply by from composite function minus 1 because we differentiate what is inside and it gives us minus 1. So we have as our differential of log likelihood function of x mean sigma all over the mu to be equal to summation of ln x minus mu 2 minus 1, that is gone, all over 2 sigma squared. The next thing to do is to equate to 0. To find the maximum, we equate to 0. We equate the whole of this to 0. So we get summation of ln x minus mu all over 2 sigma squared to be equal to 0. Of course, this will go into 0 to give us this alone. So we come over to this other side of the board. We come over to obtain our mean. We come over to this place. So it then means that summation of mean x minus mean is equal to 0. Of course, we have to sum the whole of this. If we sum this, we get summation of mean x. If we sum this to open the bracket minus, if we sum a constant, we get n times that constant, which is n mean to be equal to 0. Of course, this can go over to this side to give us mean x is equal to n mean. So our mean estimate will now be equal to 1 all over n summation of mean x, which is the sample mean for the data from the log normal distribution. The mean is this. Also, to obtain the sigma estimate, which is our variance, the next thing to do is to differentiate with respect to sigma from equation star. This is our equation star. So to obtain this, we differentiate from we differentiate with respect to sigma from equation star. This is our equation star, the whole of this. So the next thing to do is to write the differential of log, the differential of log of the likelihood function as is written here, x mu sigma all over the sigma. We differentiate it with respect to sigma squared. So we have, of course, there is nothing like sigma squared here, so here becomes 0. We have sigma here, so we differentiate this. So it gives us negative 0, negative, and if we differentiate this, we get n all over sigma. Of course, if you differentiate this, there is nothing like sigma here. So we say minus 0. We also have this here. If we differentiate that function, it's quite simple to differentiate that, but we use what is called the quotient rule of differentiation, because a function here is dividing another function. So we use the quotient rule. First, we write what we are differentiating at. We write it out, which is summation of mean x minus mean raised to the power of 2 all over 2 sigma squared. So this becomes our u, this becomes our v. And the quotient rule states that v du all over the sigma minus u dv all over the sigma all over v squared. So this is what we do. We differentiate that first before we put what we got here. We come over to this side. So we come over to that side. What is our v? Our v is this. Our v is our v is 2 sigma squared. So here we have the u all over the sigma, the u all over the sigma. Since there is no function of sigma or sigma squared here, we have 0 minus Here we have u. We bring down our u. We bring down our u, which is summation of min x minus min all squared multiplied by, here we have dv all over the sigma. dv all over the sigma. If we differentiate this, we get 4 sigma only all over v squared, which is 2 sigma squared raised to the power of 2. So it then means that if we cancel that, this becomes 0. It becomes, this is 0 minus, we get 4 sigma summation of min x minus mu all squared all over 4 sigma 4. So this will cancel this. This one will cancel this to give us 3. So what we write here is what we've gotten. Negative summation of min x minus mu raised to the power of 2 all over sigma 3. This is what we get. It then means that our differential of our log likelihood function of x, mu, and sigma all over the sigma is equal to what we get here. Of course, this multiplied by this will change this thing to positive sign. So we have summation of min x minus mu squared all over sigma, sorry, let me write everything else to be elaborate. So what we get here, we have negative n all over sigma plus summation of min x minus mu raised to the power of 2 all over sigma 3. So the next thing to do is to equate this to 0. Equate to 0. We have negative n all over sigma plus summation of min x minus mu raised to the power of 2 all over sigma 3 equal to 0. Of course, this can go over to this side to give us negative n all over sigma is equal to negative summation min x minus mu raised to the power of 2 all over sigma 3. So this will cancel this. The next thing to do, we've already gotten our mean to be this. So we are looking for our variance. We shouldn't forget our mean is this. Our mean is 1 all over n summation of min x. Also, since we have this and this can come over here, while this go over to this other side. So we can have sigma 3 all over sigma to be equal to summation of min x minus mu raised to the power of 2 all over n. Of course, this will cancel this to give us square. So we have sigma squared to be equal to summation of min x minus mu raised to the power of 2 all over n. If we square both sides, square both sides. If we square both sides, it means we get our estimate, our sigma estimate to be equal to the square root of summation of min x minus mu raised to the power of 2 all over n. So this becomes our variance and this becomes our mean estimate. This is how we can estimate the expectation or the mean and the variance of the log normal distribution. For more on this topic, you need to subscribe to this channel.